Hello, everyone. Very good evening and welcome back to Byju's Exam Prep. So, let's start with the last session for today. Let's take up some of the remaining disasters. Let's take a look at the geophysical hazards, starting with earthquakes. We will also study tsunamis as well and take a look at some other hazards like biological hazards. Right? So, that is what we have left for today. So, let's begin with the discussion on earthquakes. How does it occur? What is its impact? And what can we do to manage the disaster, to mitigate the impact of the disaster? Because mitigation is the only option. You can't prevent earthquakes, right? It's beyond human capabilities. So we just have to deal with the impact, and through better planning and preparedness, we can definitely minimize the impact of earthquakes. So this particular hazard is a instantaneous hazard, and it has tremendous destructive potential. Is that clear? Earthquakes along with volcanoes both are very closely related to the same geophysical phenomena which drives them. And these hazards, they have tremendous destructive potential. They can potentially wipe out life on Earth. They can be potentially apocalyptic events which can completely uproot human life. So these destructive hazards, they do pose a threat. And around the world, there are many zones, many seismic zones, which are vulnerable to earthquakes, volcanoes, and other related hazards. So let's start with the earthquake and then we'll focus on volcanoes and tsunamis as well. So, what exactly is an earthquake? Earthquake is essentially the trembling of the Earth's surface, the shaking or trembling of the Earth's surface, which is induced by the seismic waves. The seismic waves that are released, right? They can cause the trembling of the Earth's surface. They can shake the Earth's surface, causing the buildings and anything that's tied to the surface to tremble and shake as well. The biggest threat from earthquakes is to the buildings. Anything that we have constructed, anything that we have built on the surface with the foundation going inside the earth, right? Because see, imagine if an earthquake were to happen in a deserted area. Just imagine hypothetically, there is an uninhabited island. There are no humans, no buildings. And in such a place, if there were to be a massive earthquake, it won't really have much of an impact, right? The real threat from earthquakes is to our buildings, to everything that we have constructed on the earth, where we have built the foundation into the earth. So, this trembling of the surface can shake the foundation, leading to the collapse of the building itself. The structure could fail, leading to the complete collapse of the building, and that is where people get killed. That is where people get trapped. Is that clear? Along with that, earthquakes can contribute to secondary, tertiary disasters. We've already mentioned that quite a few times. Earthquakes can lead to landslides, like in the Himalayan belt, which in turn can cause floods, right? Earthquakes can have disastrous impact on industries and offices because when buildings collapse, the electrical wiring could get short circuited, triggering fires, and even the people who are trapped could get killed by the fires. So there are many cascading effects of the earthquake. That's what makes it really destructive and dangerous. So these seismic waves, which cause the trembling of the surface, they are released in the interior of the earth. In the interior of the earth, between the crust and the mantle, you have your tectonic plates, which are in constant movement. You would have studied in geography about tectonic plate movement, continental drift theory, right? At one point, all the continental landmass that you have today, all the continents, they were all united. They were all part of one ancient landmass, which we call the Gondwana land. But over millions and millions of years, these tectonic plates, which are sitting on fluid matter, that's your magma and lava, right? That causes the plates to drift away from each other. So today, the world's map looks very different. The landmass is distributed in a different position. But these tectonic plates are active. They are still active. They are in constant movement and they brush up against each other. So at these seismic zones or these tectonic fault lines, at these fault lines where two or more tectonic plates meet, right, there is constant movement which is happening. Now imagine you built a big building or a tower and the foundation itself is shaky. What will happen to the building, right? The constant shaking and movement could bring down the building itself. So something similar is happening inside the earth. The tectonic movements is directly responsible for the rupture of the fault lines that releases tremendous amount of energy which travels through the earth's interior as seismic waves. The energy that is released at these zones, these subduction zones, right, it travels throughout the interior of the earth, reaching the crust and the surface. And this is what it's this energy that causes the shaking of the surface of the earth. Now these tectonic plates are in motion. Some plates are brushing up against each other. Some plates are drifting apart, forming rift valleys. Some plates are diving under another plate. Like, for example, the Indian plate, right, dives under the Eurasian plate. It is this subduction of the Indian plate under the Eurasian plate which gave rise to the Himalayan mountains. Right? When the Indian plate crashed into the Eurasian plate and subducted, that's what pushed up the matter above, leading to the formation of the Himalayas. So, this is a constant motion that is taking place in the interior of the earth. So, just like the Himalayan belt, there are different zones in the world which are very active seismic zones. So, across these regions, the constant movement of tectonic plates at the fault lines can lead to ruptures. The plates which are rubbing up against each other or drifting apart or diving under each other, right, they could go into a sudden movement which releases this tremendous amount of energy which is held, and this travels as seismic waves through the interior, reaching the crust and the surface. So the exact point in the interior where the rupture happens, right, where the energy was released, this point is called the focus point. Please remember this for your prelims. Note down this for your prelims. The exact point where inside the interior of the earth, between the crust and the mantle, where exactly the tectonic rupture happens at the fault line, that point is called the focus of the earthquake. Now from here, you draw a straight line to the surface. You draw a straight line to the surface of the earth. This point on the surface of the earth becomes your epicenter. You might have read in newspapers that if an earthquake happens somewhere, they will identify which was the epicenter. Like the recent Nepal earthquake, the recent earthquake in Turkey and Syria, right? The exact epicenter was identified. In the case of the Turkey Syria earthquake that happened few months ago, Gaziantep, which is a major town in Turkey, that was identified as the epicenter. So epicenter means it is that point on the surface of the earth where right below that point, that is where the rupture had occurred. That is where the focal point was located. Is that clear? Epicenter is the point on the surface of the earth. Now you go straight below from there. That's where you'll find your focal point, where the tectonic rupture happened, which released these seismic waves that travel through the interior, reaching the surface of the earth. Is that clear? So this sudden release of energy following the rupture of fault lines is what causes the trembling, leading to this phenomena, this hazard called earthquakes. So the various factors apart from plate tectonics that cause earthquakes includes the destabilization of fault lines, which I was mentioning, right? These are two related phenomena. Plate tectonics, that is the tectonic movement, with the destabilization of the fault line. Apart from that, even volcanoes, volcanic eruptions, very powerful volcanic eruptions, can trigger earthquakes in the nearby region. Both are related phenomena, by the way, right? The hot lava magma, right, which is still cooling down from millions and millions of years inside the earth, this could erupt outside, leading to a massive volcanic eruption. These volcanoes will throw out toxic gases, hot lava, and magma, and the forceful explosion that happens, right, can trigger a massive shock wave that will induce an earthquake in the nearby region. So, volcanic eruptions can also be a contributing factor. Apart from these natural causes, it is possible for man made earthquakes to happen as well. Of course, you can't compare the scale, right? The man made earthquakes or human induced earthquakes can never be as powerful as the natural earthquakes. But still, there are some human activities which can cause a slight trembling, which can mimic the events of an earthquake. For example, nuclear explosions, especially the ones that are conducted underground. Underground nuclear explosions, usually done for the purposes of testing nuclear weapons. This can induce shock waves that will travel through the surface of the earth, causing trembling, causing earthquakes in the nearby region. But like I said, it won't be very powerful. It won't harm or cause significant damage as such, except maybe in the nearby area. Like Pokhran tests of India. Right? At Pokhran in Rajasthan, we conducted an underground nuclear test. And these tests, they did release shock waves, which would affect the nearby villages. And the shock waves can be detected even in faraway places. In fact, this is one way through which countries detect the nuclear tests of other countries. We even have a global organization called CTBTO, all right, the Comprehensive Test Ban Treaty Organization. It's the task of CTBTO to identify any nuclear tests which are conducted, be it tests on surface or in the atmosphere or under the water, under seas and oceans, or even underground. CTBTO tracks any nuclear testing, and one way of detecting underground nuclear tests is by detecting these shock waves that are generated. All right. But however, these shock waves are different from the seismic waves that are generated through plate tectonics and the destabilization of the fault lines. So, natural earthquakes are the real danger. They are the ones which can cause very significant damage. They are very destructive. Human induced earthquakes can have some local impact, localized impact, but not beyond that. Even large scale mining and tunneling work can lead to human induced shocks if underground tunneling is taking place. Like, for example, let's say metro work or underground road tunnels are being built. So, the tunneling work can weaken the structure inside, causing slight tremors and shocks, which can also be a case of human induced earthquakes. Mining activity, right? Mining, which involves explosions and tunneling, can also lead to these mini earthquakes. Then, even dams have been associated with earthquakes in the region. But however, this is a controversial theory. Not all the geologists agree on this. So there are those who say that dams which store large volumes of water in the reservoir leads to an imbalance in the surface and the interior present in that region that apparently is connected to small earthquakes that are induced nearby the dam area. But there are critics who point out that this is not proven. There isn't enough scientific evidence to back this theory, right? So it's a very controversial theory which is supported by some geologists, but some of them dismiss this. But there are some places in India and around the world where dams have been linked with localized earthquakes in that region. All right. In India, there is one such place. In India, there is one place where it's believed that a nearby dam is responsible for local earthquakes, which is happening regularly. Do you guys know which is it? Which location is that? Can you let me know in the comments? Very good, Himanshu. Himanshu has given the right answer. Very good. Have you heard of the Koyna Dam in Maharashtra? The Koyna Dam in Maharashtra is linked with the local trembling that occurs every now and then. And a lot of studies have been conducted. But again, it's not a conclusive theory. All right, it's a controversial theory. But many believe that dams indeed are playing a role in triggering these local earthquakes. So these are examples of human induced earthquakes. But please note, please remember again, I'm repeating this point. You cannot really compare human induced earthquakes with natural earthquakes. The energy released is many, many times higher in case of natural earthquakes. Is that clear? And they can't cause too much damage. Human induced earthquakes will have some local impact. Maybe in the nearby areas, buildings might crack, right? Apart from that, you won't see much damage. But natural earthquakes can be so devastating, they can flatten entire cities. The entire region could be wiped out. Every single building can come down if there is a powerful earthquake. This is the power of an earthquake, right? And the volcanic phenomena is related to it. Volcanoes, volcanoes are again a result of the tectonic activity. That's why in places where you witness earthquakes, those are the exact same places where volcanic eruptions can happen. If you look at the active volcanoes of the world today, right, if you identify them on a map, you'll notice that it coincides with the earthquake zones of the world. So both the phenomena are linked to the same geophysical process, which is your tectonic activity. Is that clear? So in a volcanic eruption, what happens? The hot magma, lava, and the gases, they are expelled. It results in a violent explosion, right, where hot magma, lava, and gases are thrown out and expelled, which can turn into a major disaster. Because these gases that are released, they can be toxic. This can harm human life. It can harm the environment. The gases which are released into the atmosphere will contain aerosols. This can disrupt air traffic. Aircraft movement can be affected because of the aerosols that are dispersed into the atmosphere. Got it? It might even lead to disruption of incoming solar radiation. Volcanoes have this potential where it can release so much gases and aerosols into the atmosphere that it can block out sunlight, leading to a winter, a prolonged winter, and potentially it can even bring us back to the ice age. Historically, there are evidence to suggest that mega volcanic eruptions, they ended life on earth by blocking out solar radiation. It's like putting a cover to the atmosphere, right? The spread of aerosols that which could spread and cover the entire atmosphere could block out sunlight for centuries together, and this could lead to a prolonged winter and an ice age that will end life on earth. So historically, we do have some records, fossil records pointing towards such an event. So in the future as well, there is a potential of such an extinction level event from happening. That's why these have apocalyptic potential. Mega volcanic eruptions can block out solar radiation for many centuries, which affects photosynthesis, which affects every living organism, which can wipe out life on Earth. The hot lava and magma that will flow, the pyroclastic flows, they are extremely dangerous, right? The temperature of the magma and lava would be very high. It will burn everything in its path. It will trigger fires, forest fires, and anything in the path will burn, triggering massive fires in the region. So that is why volcanoes are also extremely destructive and it can have a global impact. Fortunately, we haven't seen such mega volcanoes, but we do experience volcanic eruptions, which does affect locally in Iceland, in Japan, in Indonesia, in the South Pacific Islands. There have been quite a few volcanic eruptions, right? They have killed many people, they have displaced people of the nearby villages, burned down everything in the path, they've disrupted air traffic. So we have seen such incidents happening, but thankfully we haven't witnessed a global catastrophic event. Now, these earthquakes and volcanoes, they can both occur underwater as well. Don't assume that earthquakes and volcanoes are restricted to the landmass. They are not. They can occur even underwater, under your seas and oceans. Understood? This is what triggers a tsunami wave. Such massive underwater earthquakes or volcanic eruptions, which happen under the seas and the oceans, is what can trigger a massive tsunami wave. However, we'll come to that later. We'll discuss tsunami later. We'll come to it. So let's focus on earthquakes and volcanoes right now. So you can imagine the impact of these geophysical hazards. As I told you, volcanoes can lead to large scale loss of life, right? People who inhale those toxic gases, who are in the path of the pyroclastic flow of magma and lava, right? They will immediately face the impact. So there can be large scale loss of life, damage to property, infrastructure, and the environment. Same with earthquakes. Earthquakes are so destructive in their energy, right? The energy that is released, it can flatten buildings, entire cities can be brought down, killing thousands and thousands of people. Is that clear? So, earthquakes as well cause enormous financial and economic damage. Your infrastructure could be completely destroyed. Critical infrastructure. Is that clear? Power plants, dams, then key facilities like, airports, seaports, they could all suffer significant damage, causing widespread economic destruction and losses. So, both the disasters, they require maximum attention, right? So, let's see what is the distribution of earthquakes and volcanoes in the world. Which parts of the world are most affected, and where does India stand? What is India's vulnerability to earthquakes and volcanoes, and what is the global distribution? So, I'll be showing you a couple of maps to help you understand the distribution of earthquakes. We will talk about two specific regions. One is the Circum-Pacific Belt, also popularly called as the Pacific Ring of Fire. I'm sure you all would have heard about this name since your school days, right? The Circum-Pacific Belt, or popularly known as the Pacific Ring of Fire. These are the regions it covers. I'll show you in the map as well, don't worry. The other major region, which is a hub of earthquakes and volcanoes, happens to be the Alpine Belt, the Alpine Himalayan Belt. These are the two major tectonic zones of the world. But amongst the two, the Pacific Ring of Fire witnesses 68% of the earthquakes suffered on Earth. Is that clear? There are two major zones. One is your Pacific Ring of Fire, the Circum-Pacific Belt. The other is the Alpine Himalayan Belt. All right, these are the two major hubs of all earthquake and volcanic activity. But majority of them, almost 70% of it, happens in the Circum-Pacific Belt, in the Pacific Ring of Fire. So let's see where exactly these regions are located, and we'll also identify few other places such as the rift valleys and the ridges in the Atlantic, in the Africa, etc. Let's take a look at where these earthquakes and volcanoes happen. Now please observe, look at the map carefully. You can see here from Alaska, this is Alaska of United States, right? And this is Canada, this is US, Mexico, and you have your Central America region, correct, and your South America region. So along the entire west coast towards the Pacific, this is the Pacific Ocean, the entire west coast of these two continents, from Alaska, Canada, US, it includes California as well. California is very, very prone to high intensity earthquakes. Mexico as well, right? Central American countries like Guatemala, Nicaragua, and across the coastline of Western South America, that is Peru, Chile, they're all highly prone to high intensity earthquakes. This is also a volcanic zone. There are few volcanoes, some are active, some are dormant, and these hazards that are present can lead to major disasters. Mexico has seen some devastating earthquakes. California, Alaska, Peru, and Chile, they have seen some major earthquakes in the past. In the future as well, it can happen again. Now, look at the opposite side of it, the exact opposite side of the Pacific. I'm talking about this region here. This covers Japan, parts of eastern China and the Korean Peninsula, all right? Then parts of Southeast Asia, like Philippines. This comes towards India as well, towards Indonesia. This belt extends very close to our Andaman Nicobar Islands, which we were discussing earlier. If this is Andaman Nicobar, this green dot, right next to it, the Pacific Ring of Fire passes via Indonesia. So from here, it covers Papua New Guinea and towards the eastern part of Australia and New Zealand, and covers the South Pacific island countries. In the South Pacific, over here, you have countries like Vanuatu, Fiji, Solomon Islands, right? Palau, they're all vulnerable to earthquakes and volcanic eruptions. You have many active volcanoes here. So countries like Japan, then Philippines, Indonesia, they are the most affected. Indonesia especially is another major country that faces multiple disasters. Indonesia is hit by earthquakes, volcanoes, tsunamis, and many more. Is that clear? So in Indonesia, you have many active volcanoes. If you have been to Bali, the popular tourist destination, you would have heard about Mount Batur. You might have visited Mount Batur as well. It's an active volcano. In the nearby islands, across the Lombok Strait and in the Sulawesi Sea, there are many active volcanoes which keep erupting every now and then. In the last few years itself, there have been 2, 3 major volcanic eruptions. There have been multiple underwater earthquakes that have triggered tsunamis as well in this region. One such event was the 2004 tsunami, Indian Ocean tsunami. It was triggered by an underwater earthquake that was generated near Sumatra. Sumatra is the northernmost island of Indonesia, very close to our Andaman Nicobar Islands. So, nearby Sumatra, this mega earthquake occurred under the Indian Ocean that triggered a tsunami wave that caused massive destruction across this region, including India. Right? We studied yesterday more than 1 lakh people were killed in Tamil Nadu, in other states along the east coast, in Andaman Nicobar. It affected many other countries: Sri Lanka, Maldives, Thailand, Myanmar, Bangladesh, Indonesia itself, even East African countries. They were all affected by the tsunami. So you can imagine the energy that is released in an earthquake. If a tsunami wave could travel such a far distance within few hours, imagine the power of the earthquake, the energy that is released. So this belt, which I have highlighted here, is your circum-Pacific belt. All right. It's called the Ring of Fire because if you look at the Earth, I mean, if you look at the globe, right now you're looking at a 2D map, correct? If you fold this, if you imagine a globe, right? If you imagine Earth, which is a sphere, a spheroid, you will see that this forms a circle. This specific belt we were looking at, it actually forms a circle, right? That is why it's called the ring. It's like a ring, it's like a circle. Fire is added here because this is a site of volcanic eruptions. What happens in volcanic eruptions? Magma, lava are spewed out. That is why this circum-Pacific belt is called the Ring of Fire, the Pacific Ring of Fire. Is that clear? There are minor faults within this Ring of Fire. You have your East Pacific rise, the San Andreas Fault, which affects California and Mexico. California and Mexico are hit regularly because of the disruption that happens at the San Andreas fault line. Is that clear? So this is one of the most vulnerable regions, from Indonesia to Japan to US to South America, all the way to South Pacific Islands. Is that clear? So the other region, the other belt where most of the earthquakes are concentrated and volcanoes are also present, is the Alpine Himalayan belt. The Alpine belt is where the Alps mountain ranges are present. Where is it located? It's located in the Mediterranean, in southern Europe. This belt stretches here. Actually, if you further look at the belt, it actually traverses under the Atlantic and almost connects with the Pacific Ring of Fire in Central America and Mexico. That's where the belt originates from. This ridge, this rupture point originates from. Passes via southern Europe, that is in the Mediterranean. That's why countries like Italy, Greece, Cyprus, they're all very, very vulnerable to earthquakes. The Alps region, the Mediterranean belt, the Balkan countries, they are the most affected in Europe. All right? This fault further extends towards West Asia. If you look at the map carefully, you will see many earthquake points concentrated here in the Gulf region. So, Turkey, then Syria, Iran, and few other countries present here at this junction. They are all highly vulnerable. Iran witnesses some devastating earthquakes. The most recent one was the Turkey-Syria earthquake. Just few months ago, right? Turkey and Syria were devastated by this massive earthquake. So here, there are three major plates which are interacting. You have your African plate that meets with the Arabian plate, and you have the Anatolian plate on which Turkey is sitting. The Anatolian plate. I'll write this here. The Anatolian plate. So near Turkey and Syria, there is a trijunction of three plates: the African plate, Arabian plate, and the Anatolian plate. So that is why even across Jordan, Israel, all the way till Egypt, there exists a fault line. And this region can potentially witness some massive earthquakes in the future. Is that clear? Now this line extends further. It extends towards Afghanistan, Pakistan, and Central Asia. That is why Central Asia also witnesses earthquakes. Afghanistan is very vulnerable. Just yesterday, you would have read news reports, right? In the last couple of days, there has been a massive earthquake in Afghanistan. More than 2,000 people have been killed. In fact, in the last 1.5 years, this is the third major earthquake to have happened in Afghanistan. Already around 8 to 10,000 people have died in Afghanistan just in the last 1.5 years. Pakistan is very vulnerable in the Kashmir belt. right, in the Kashmir region, which is occupied by Pakistan, right? The region is very prone to earthquakes. POK has seen some massive earthquakes in the past. Back in 2005, Muzaffarabad, which is the capital of Pakistan occupied Kashmir, witnessed a massive earthquake where many people were killed. So from here, the line extends towards India, towards the Himalayan belt. That's why from Jammu and Kashmir all the way till Arunachal Pradesh, the entire Himalayan belt is extremely delicate and sensitive. Here, the Indian plate is diving under the Eurasian plate. It's a subduction zone, an active subduction zone. Is that clear? So, Himachal Pradesh, Uttarakhand, J&K and Ladakh, Nepal, Sikkim, Bhutan, and Arunachal Pradesh. This whole region is very vulnerable. Even as we speak, the Indian plate is constantly diving, subducting under the Eurasian plate. This is what is lifting up the material upwards, leading to the formation of Himalayas, and that is why the Himalayan mountains keep growing in height. You would have read about this in your school or in your geography classes. Himalayas are constantly growing in their height because of this active subduction which is happening. So that is why the Himalayan mountains are immature. They are more recent and it's very unstable, right? They are young fold mountains. So the whole belt here is a very active seismic zone, and the region around it, the North Indian plains and the Northeast region, is extremely sensitive to the impact of these earthquakes. Understood? So from here, the region enters Southeast Asia towards Myanmar and almost touches with the Pacific Ring of Fire. So Andaman Nicobar, which is quite close to the Pacific Ring of Fire, is also vulnerable, and we have an active volcano in India, as we discussed yesterday. Andaman Nicobar has the only active volcano of India at Barren Island. It has been active in the last few years. Some eruptions have been detected, and recently a submarine volcano has been detected. Just a few days ago, a research paper was published by Indian researchers, and they have identified a new submarine volcano, underwater volcano, closer to Barren Island at a point called Crater Sea Mount, at an underwater point in Andaman Sea called Crater Sea Mount, which is near Sumatra. Over here, a submarine volcano also has been detected, right? Of course, it needs further scientific confirmation, but this could very well become the second major volcanic zone of India. So right now, the only active volcano is Barren Island. It's on land. All right, it's a volcano present on land, but this detection of a submarine volcano is a new development. But we have never seen any major eruption as such, at least in the recent times. But definitely, we are very badly affected by earthquakes. That is for sure. Got it? Now, let's look at some other regions here. Can you see this mid-Atlantic ridge? This is another major fault. It runs in a north-south direction, right? Almost from the Arctic to the Antarctic. This is another major fault line in the Atlantic Ocean, right? It's under the Atlantic. So this could also lead to ruptures causing earthquakes and eruptions, volcanic eruptions that could cause a tsunami as well. So in a way, this mid-Atlantic ridge almost connects with your Pacific Ring of Fire, correct? It extends across into Indian Ocean, in the South Indian Ocean. From here, it extends to the North Indian Ocean, hitting Africa and the Arabian Plate. Now, from here in Africa, you have a major rift valley which is forming, the Great African Rift Valley. Have you heard about it? The Great African Rift Valley. Over here, the African plate is splitting apart. It's a rift region where the plates are moving apart, and in some time in the future, you will see that this whole region, this part of East Africa, will break away. It will become an island. The sea, the ocean will enter into the rift, pushing this region outside, causing this region of East Africa to become a island of its own. Of course, it will not happen in few years. We'll never witness this. It will take millions of years. But that is what is happening. Now, if you guys have ever been to Kenya, Tanzania, right, you can see the Great Rift Valley, the Great African Rift Valley. You can see how the landmass has flattened. There is a depression, and the landmass rises on the other side. It's a great, beautiful sight. There is another rift valley in the Middle East, the Jordan Rift Valley, present along the Dead Sea. It's right next to West Bank and Israel, right? Between Jordan, West Bank of Palestine, and Israel, you have the Jordan Rift Valley, right? This is another rift region which could move apart and break, causing these changes, these geographical changes on the surface. So these are some basic details that you should be aware of, right? The major fault lines, the ridges, where they are present, how they lead to these mega disasters, what is the impact of these disasters. So that is a common understanding any UPSC aspirant should have. All right. So the impact is very clear, very evident. Earthquakes can lead to massive loss of lives, severe injuries. Not just thousands of people, lakhs of people, but millions of people could be affected. A powerful earthquake of a sufficient magnitude can wipe out the entire region. So the potential for the disaster is very immense, and it's very, very destructive. It can cause severe damage to infrastructure, leading to secondary disasters like fires, flash floods, landslides, and tsunamis. This is where earthquakes become really dangerous. It will have a cascading effect, a chain reaction or a domino effect, where one disaster leads to another, causing multiple disasters to affect the region. Got it? Now, can anyone tell me, how do we measure earthquakes? Any idea? How do we measure earthquakes? Someone in the comments? Doctor scale. What is doctor scale? Vivek says Richter scale. No, Richter is not the right word. Abhinav and Avani, Himanshu, Chituri have got it right. We measure earthquakes using a seismograph. That's the instrument. All right, it can detect the seismic waves and it can plot the waves on a graph. The instrument is called a seismograph. But to measure the magnitude, to quantify the magnitude, we have developed a scale called the Richter scale. Is that clear? The seismic graph or seismograph, it's very, very sensitive instrument. It can detect the minutest of vibrations and it will plot this on a graph. This is quantified through the Richter scale. So that's why when earthquakes occur, we say that this earthquake was of a magnitude 6, magnitude 7, magnitude 8, 9, etc. So any earthquake of a magnitude of less than 4 is a very minor event. Nothing is likely to happen if it's under magnitude 4. Under magnitude 4 earthquakes are pretty much okay. They won't cause much damage. You will only feel slight tremors. Maybe some old buildings and some weakened buildings might suffer some cracks, not more than that, right? Not much damage will happen. But once the magnitude hits 5 to 6, you will start seeing some damage. Even 6 magnitude earthquakes can cause sufficient damage if your buildings are not strong enough, if your cities are not well built to withstand earthquakes. 7, 8, 9, and above, they can cause massive, massive destruction. We have seen many 8 magnitude earthquakes, but 9 and above is very, very dangerous, very devastating. And the worst part is that there will be aftershocks. After the initial earthquake, right, which causes tremendous trembling and shaking, honestly, it's quite scary, right? You can't imagine that. If you've ever experienced it, you'll know how scary and dangerous it can be, right? So after the main earthquake hits, there will be many aftershocks that will last for several days. Within few hours, there will be more aftershocks. After 1 day, after 2 days, the aftershocks continue, and even these aftershocks can cause damage. All right, it's a very traumatic experience as well to be in such buildings which are shaking. And if the building were to collapse, even if you survive the disaster, you will be permanently traumatized. It will lead to emotional, mental distress. You will suffer from PTSD, post traumatic stress disorder, right? So, people who experience severe trauma, like being in a war or witnessing a death, right? These are highly traumatic events. Similarly, experiencing an earthquake firsthand or any disaster for that matter can be a very traumatic experience. Is that clear? So, earthquakes can have such devastating potential. Now, if you look at India, there are major seismic zones in the country because we are part of the Alpine Himalayan belt. We are very close to the Pacific Ring of Fire. Apart from that, there are a few other fault lines which causes major earthquakes in some parts of the country. All right, but fortunately, majority of the country is safe, especially the peninsular plateau. Right, this is a very stable region, very old region, going back to the Gondwana era. Rest of it is very vulnerable. So the hazard vulnerability map of India has been developed. You can see the hazard prone areas, which are clearly designated into different zones. Zone 1 to zone 4. Oh, sorry, zone 2 to zone 4. There's no zone 1 here. Zone 2 to zone 4. Zone 5 represents the highest risk. That's why they are marked in red. Zone 5 represents the highest seismic risk, followed by zone 4. These two face the biggest risk. So it's coded in orange. Zone 2 and 3 are pretty safe. They will face tremors or aftershocks, but they won't face much significant damage. So if you observe the map, you will see that the old landmass that makes up India, the peninsular landmass, which is part of the Gondwana land, this is a very stable region. All right. So that's why these western, central, eastern, and southern parts of India, they are very safe. They are very stable. This part, which I've highlighted, nothing will happen here. Maximum is they'll witness some tremors, some aftershocks, nothing apart from that. There is one small region near Maharashtra here, which is the Koyna belt, the Koyna Dam region. This is where there is a theory that the dam is responsible for the tremors. All right, but again, it's not conclusively proven. Apart from that, there is one region in Gujarat, the Kutch region. It extends to the Sindh province of Pakistan as well. This is very prone to high intensity earthquakes. There is a fault line here, and that is why Bhuj was devastated around 2 decades ago by a massive earthquake that hit the region. In 2000, there was a mega earthquake in Bhuj that caused enormous destruction in the Bhuj region. Next, of course, is your Himalayan belt, the northeast region, and Andaman Nicobar. Andaman Nicobar, the whole of Andaman Nicobar is zone 5. The entire northeast India is zone 5. Parts of the Himalayas in Kashmir, Himachal, Uttarakhand, Nepal, right? They're all under zone 5. When I say Nepal, I'm referring to the Terai belt near the UP Bihar border. The rest, the orange area you see here, the foothills of Himalayas, which covers Jammu and Kashmir, whole of Himachal and Uttarakhand, Delhi NCR. Delhi is right in the line of fire. Our capital is in zone 4. The whole Terai belt. going all the way till Sikkim. This entire region is zone 4. So these are the high risk zones of India. All right. Now, do you know which is the nodal agency to detect earthquakes and measure earthquakes? Let me know in the comments quickly. Let's wrap up this topic quickly. We're at the end. Let me know which nodal agency is responsible for detecting and measuring earthquakes in India. Chituri and Akanksha have given the right answer. Very good. IMD, India Meteorological Department. All right, IMD again is the designated nodal agency. Now, coming to the last point, how do we manage earthquakes? How do we deal with them? What can we do as part of disaster management? First step, as we already know, is risk analysis. So, you study the disaster, you conduct geological studies, you use historical data to understand which are the prone regions. You create your hazard vulnerability map. Now, once you identify the priority areas, the first focus has to be zoning. Identify the high risk zones and regulate all the construction in that zone, especially in zone 5 and zone 4. Land use planning is critical, where we have to enforce building standards. Building codes have to be strictly enforced because we can make our buildings, our infrastructure, earthquake proof, or at least earthquake resistant. It's very important to build disaster resilient infrastructure. It's very, very important to build disaster resilient infrastructure which can withstand the impact of disasters. Thanks to advances in civil engineering, in construction technology, in architecture, today it is possible to make your buildings more secure. If not 100% foolproof, at least most buildings can withstand and suffer very minimal damage, right? But this requires very strict land use regulation and strict enforcement of your building construction codes and standards. This is where India is lagging behind. In this regard, we are the laziest people in the world, right? I'm not even kidding. I'm not undermining what I'm saying. Especially the northern belt of India, right? The Himalayan belt and the region next to it, that includes Delhi, our own national capital. They are in the line of fire. And trust me, we are not prepared. If a 8 or 9 magnitude earthquake hits this region, the devastation will be unimaginable. 99% of our buildings are not earthquake proof and earthquake resistant. The blame lies entirely with the government, right? Or even in general, people as such, they don't follow the rules. The laws exist. It's not that we don't have enough laws. The standards are there, but there is no enforcement from the center, state, and your local bodies. See, center has done its part. It has come out with the land use planning and the zoning standards. Problem is, state governments, your local bodies are not enforcing them properly. This is primarily due to corruption. Your municipal bodies, corporations, town planning bodies, they are highly corrupted. Same with state administration and even to an extent at the center. There is a very, very big nexus in our country between politicians and the real estate industry. There is an involvement of government officials as well. This corrupt nexus is allowing this illegal encroachment to thrive and the violation of these laws to happen. Most buildings, even today, which are being built, forget the old ones. Even today, the massive malls and apartments which are coming up, right, even by reputed builders, they are not earthquake resilient. They're not including these standards because to make the changes, it will be very expensive, very costly. So they bypass the laws. They pay bribes to politicians and officials. There is a clear nexus between them, and they conveniently bypass the safety norms. Now, this is where we should learn lessons from Japan. Japan is miles ahead of any other country when it comes to disaster planning. Japan is one of the most forward thinking nation in this regard. Since the country is very vulnerable, it has secured itself through disaster resiliency. See, they can't prevent typhoons, they can't prevent earthquakes, they can't prevent volcanoes or tsunamis. So, what they have done, they have planned, they've prepared, and they have mitigated the impact. Even if massive earthquakes hit Japan, the loss of life, collapse of buildings is minimal. Even if tsunamis hit Japan, damage is very minimal. Is that clear? So, this is where countries like India and others, Indonesia, all these countries are very vulnerable. We have to draw lessons. You can't sit and wait. These disasters can happen any moment. You never know, it can happen tomorrow, right? And you can't risk your entire cities, your entire population without taking these basic measures. Even now, it's possible to strengthen and retrofit old buildings as well. At least some priority structures like infrastructure projects, power plants, nuclear plants, dams, they can even now be retrofitted, meaning you can conduct changes in the structure, in the engineering of a building or a structure, and make even old buildings disaster resilient. If not proof, at least resilient. But we are not undertaking the measures. But most of the big projects, at least nuclear plants, they are earthquake resistant. The new government buildings, like for example, your new parliament, the new secretariat which is coming up along Rajpath, right? All these new buildings, new structures, they are earthquake proof. All the modern designs have gone into it. All our nuclear plants, they are mandatory by International Atomic Energy Agency. So all the nuclear plants of India are earthquake resistant. Is that clear? But others, which are older structures, many of the dams in India are not earthquake resistant. Most of the private properties, houses, offices, shopping malls, apartments, none of them, at least 99% of them, they are not earthquake resistant. So if a tragedy were to occur, forget 8, 9 magnitude earthquake, even 6 or 7 magnitude earthquake can flatten most of the buildings. So that is the risk we are living with. And this is one area where we haven't performed well. So strict regulation enforcement is needed. Greater public awareness is needed. Other than that, we have to strengthen our capacities. We should invest more in research, more in scientific innovation on how we can deal with disasters like earthquakes. But of course, once the disaster happens, you have to be very, very effective in your relief and response because the damage can be severe. When millions of people are trapped, hundreds and thousands of buildings have collapsed, it's not an easy task to conduct search and rescue, right? You need specialist forces, well trained, well equipped. They will need earth moving equipment like bulldozers, JCBs, cranes. You need advanced firefighting capabilities. Multiple fires will break out in buildings and industries when there is an earthquake, right? You will need even canine squads, drones, robots, thermal scanners to look under the debris to identify people who are trapped. Because it might take many hours, few days to clear the debris. All the concrete and steel would have collapsed. Hundreds of people could be inside. You can't even access the places where people are trapped, right? You have to remove everything, clear off the material. So you need special equipment. You need canine squads. Dogs can be very effective. They can detect survivors. They can even deliver food and medicines to the trapped people. Drones and robots can be very, very critical in response and relief. They can navigate very small corners. give you visuals of where people are located, and even send medicines and food for them to help them survive till the debris can be removed. They'll need cutting equipment to cut through concrete and steel, right? You need advanced cutting equipment, gas cutters, laser cutters would be needed to cut off all the debris and throw them and remove them so you can reach the trapped people and then rescue them. So these are critical measures that need to be taken, right? In India, the disaster response forces, fortunately, they have the resources. NDRF, SDRF, they've got special training in this. They have special equipment for this. So India's biggest problem is the building standards which we have not enforced. Got it? So post disaster, what do? After the earthquake has happened, you focus on long-term recovery, reconstruction, and rehabilitation. You have to rebuild your cities. People would have lost their homes, their jobs, rehabilitate them, try to recover the region. But that will definitely take many, many years of effort, right? So earthquakes are extremely devastating compared to some of the other disasters. Next, a related hazard is tsunami. Tsunami is linked to earthquakes, volcanoes, and even underwater landslides. So let's understand what is a tsunami. How is a tsunami triggered? What damage does it cause? And what factors contribute to it? A tsunami is essentially a series of very long wavelength waves generated in large open water bodies. Usually, it will happen in seas and oceans. See, even in lakes, rivers, ponds, etc., if something were to crash, right, even that could trigger a mini tsunami like wave causing floods. But a true tsunami happens in large water bodies like seas and oceans. Is that clear? These are a series of very long wavelength waves. They are triggered by certain underwater activity, and it will lead to displacement of a massive volume of water. And these waves, as they approach the coastline, they will climb in height. They can reach a height of 12 feet, 14, 15 feet. We have even recorded 18 feet waves that can strike with destructive force on the coastline. And it won't just be one wave, there can be a series of waves that will come one after the other. So tsunamis are very, very destructive for the coastline. Is that clear? So what causes a tsunami? Let's understand the mechanism and the factors. There are many natural factors which can cause a tsunami wave. Your underwater earthquakes, underwater volcanic eruptions, underwater landslides. These are the natural causes, along with extraterrestrial impact like meteorite impact. Tomorrow, if a foreign object, if a celestial object, right, maybe part of an asteroid or a meteor were to enter the atmosphere and crash into our seas and oceans, that could also generate a massive tsunami wave. Is that clear? So apart from these natural causes, there could be a human induced mini tsunami. Again, you can't compare the energy and the damage, but human activities can also cause mini tsunamis like underwater nuclear explosions. Because in the past, few major powers like US and Soviet Union, they have conducted many, many underwater nuclear tests, especially after the Second World War in the late 1940s, early 1950s. Both US and Soviet Union, which were locked in a Cold War rivalry, they conducted many underwater nuclear tests that would trigger these mini tsunamis as well, because that is the amount of energy that is released. All right. So these are the primary causes. Underwater events like underwater earthquakes, underwater volcanic eruptions, underwater landslides, along with some human induced causes. So Chile, Nicaragua, Mexico, Indonesia, they face the biggest risk. They have seen some killer tsunamis. Indian Ocean also has been a victim, right? We ourselves suffered from one such disaster in 2004. So let us understand the mechanics of a tsunami. I feel this is very important for your prelims. Why do we say that tsunami is a long wavelength wave? How is it generated? How does it travel through the sea or the ocean? And how come it suddenly climbs in height and then strikes the coastline? Right? You need to understand that mechanism. The mechanics is something you should understand. So I've shared some images which will make this easier for you. Look at the first image. In this image, there is an example depicted. You are witnessing a disruption at a fault line, at a tectonic fault line. Is that clear? This image is depicting underwater tectonic activity. At this fault line, there is a rupture which has happened. Essentially, it's an earthquake. So this event, as you know, releases tremendous amounts of energy, and this energy travels. This displacement, right? Basically, the water was pushed with tremendous force. So this energy travels through the water. The water itself gets pushed because of the rupture that has happened underwater, because of this massive underwater earthquake. Similarly, an underwater volcano where suddenly lava magma is spewed out in very large quantities can push the water, right? Leads to displacement of water. Same with landslides. Landslides can occur underwater as well because your sea floor is not a flat land. Your sea floor has a terrain, has a topography. There are underwater mountains, valleys, and ridges. So these underwater mountains might slip. Just like landslides happen on land, there can be a landslide similarly, a slippage occurring here on underwater mountains, where a large mass of material crashes into the sea. So any of these events that leads to a massive displacement of water triggers a wave. It's like a current, like a train. A train of waves, a current of waves is triggered. The energy is so massive that these waves will start traveling at tremendous speeds. You can't even imagine the speed. Tsunami waves have been recorded to travel as fast as 700 kilometers per hour. That's the speed of a Boeing jet. That is the speed with which tsunami waves can travel. And the interesting part is that these waves in the deep sea will be a long wavelength wave. I hope you understand the concept of a wavelength, right? The distance between the crest and the trough, the high point and the low point, is very, very long. It's hundreds of kilometers long. So when the wavelength is so long, what happens? You cannot experience the amplitude of the wave, which is nothing but the height of the wave. In the deep sea, in the deep ocean, where this tsunami wave was generated, the wave will be traveling at a tremendous speed, but under the water. The wavelength is so long, the distance between the crest and the trough, the high point and the low point is so long, it will be hundreds of kilometers, that on the surface, you will not even feel a nudge. Let's say there is a ship sailing over here, right where tsunami was generated, or below the ship, a tsunami wave could be traveling, but the ship will feel nothing. They'll not experience anything because this wave is a long wavelength wave with very, very little amplitude. It doesn't have height, but the wavelength is long. So, this fast moving current of waves are traveling at this tremendous speed, and they don't display any height or amplitude in the deep seas and the oceans. So the ship here is completely safe. Nothing will happen to the ship. They'll not even realize that a tsunami wave has passed below. But the moment these waves enter shallow waters, The moment they enter shallow waters, what happens? It's like applying a sudden brake. The wave will hit the landmass, the continental landmass. So sudden brakes are applied and immediately the wave compresses. The long wavelength wave, right, which was like this, it will get compressed into a very tight wave in one go, leading to the gain of height. So as it approaches coastline, right, the wave starts gaining in height. That's why before this, the water actually recedes. This is a feature that we have observed. Even when the 2004 tsunami hit India, back then we weren't aware of such disasters, right? At least at a common man's level, people weren't aware of tsunamis. Experts would know, governments would know, but we never invested in further studies because we were not experiencing such disasters regularly. So when the tsunami wave hit India across the coastline, like especially in Chennai, at Marina Beach, which is a popular tourist destination, people saw that the sea was receding. Even at Rameshwaram, at Kanyakumari, they saw that the sea receded by several meters. They were shocked, they were surprised. That's because the water levels are getting altered. Because of the speed at which the wave is traveling, right? And all of a sudden it's about to build in its height. The water near the shore recedes, it goes back. And then when the wave is compressing here, it gains altitude, it gains the height, reaching almost 15 to 18 feet. 10 to 12 feet is guaranteed. 15 to 18 feet is also possible, depending on how much energy was released. So these waves will crash into the coastal area one after the other. At least 3 4 waves will be generated. They will literally slap the coastline with massive energy. Imagine so much water, the entire column of water crashing. So everything present here will be destroyed. The infrastructure, the boats, the property. Don't even ask about the people present here, right? They'll be wiped out. It's very destructive again. So all the facilities on your coastline are at great risk. It's a very, very grave danger. Hotels, resorts, seaports, airports, all the beaches and tourist locations, right? Power plants, any such critical facilities, everything will be smashed. It will be wiped out. And then there will be coastal flooding. The disaster does not end here. The strike of the tsunami wave is only one part of the disaster. The water will gush inside into the coastal area. It could move at very fast speeds inside the coastal area, almost up to 5 to 10 kilometers inland. That entire region will get flooded, killing even more people, destroying even more infrastructure. Is that clear? So that is the devastating power of a tsunami. So this is one disaster. This is one disaster which can be detected in real time. Thanks to the advances in technology, you can build a very, very effective early warning system. All right? You can detect the generation of a tsunami wave in real time. You can track the movement of the wave and accurately estimate. You can provide a very accurate estimation of the place and time where the wave is going to strike. So this is possible today. So big powers like Japan, US, Australia, and finally India also has joined the ranks where they can provide early warning for tsunamis. Indonesia as well has invested in the technology because it has to. It is affected by so many tsunamis. So for India, the 2004 tsunami was a wake up call. We were completely unaware when the mega earthquake hit near Sumatra underwater, right? The wave was traveling for almost 1 to 2 hours. It struck Andaman Nicobar immediately. Then we still had enough time to save people on the east coast, but we weren't aware. We didn't have any early warnings available, right? So once the tsunami wave hit all these countries across Indian Ocean, lakhs and lakhs of people were killed. In India alone, more than 1 lakh people were killed. East Africa was affected. Maldives, Sri Lanka, which is quite far away, they were all affected, including Myanmar, Thailand, Bangladesh, and Indonesia. So you can imagine the impact of such tsunami waves. So today we have an early warning system in place. We have a network of sensors. We have deployed a network of sensors underwater and on the surface of the water. There are underground earthquake, volcano, landslide detectors that we have installed across Indian Ocean. All right. Immediately, let's say there is an earthquake or a volcano or a landslide. If there is a sudden displacement of water, it is detected by the sensors and the data is relayed to these buoys which are floating on the surface. These buoys will have the communication equipment to relay this data to satellites in orbit. The moment a tsunami wave is generated due to any underwater activity, immediate trigger is sent out by the sensors on the seafloor right to this buoy which is floating on the surface. Many such buoys have been installed across Indian Ocean by India. This data gets relayed to satellites. Immediately alert goes out to all the concerned authorities, even to the media and the public. Understood? Satellites can track the tsunami wave. Once the wave is detected, we have sea observation satellites which can track tidal movement, changes happening in the sea dynamics. So satellites can give further data regarding the speed at which it is traveling, and through this we can accurately estimate which areas will be hit at what time. So once you have the ETA, the estimated time of arrival, immediately alerts can be sounded all across the coastline, pushing the people to evacuate as soon as possible. Is that clear? Today we have a very sophisticated early warning and alert system. It can give real-time alerts. You will still have 1 or 2 hours left before the tsunami can strike, which is precious time and plenty of time to pull out people from at least 3 to 4 kilometers from the coastline. So across east coast of India, which is the most vulnerable, cyclone shelters will become tsunami shelters when there is an alert. All the authorities will deploy on the ground immediately. The district authorities, the DC, the SP, all the police officials, they'll spread out across the district, urging people to move out. They will get a SMS blast. All of them, all the mobile phones in this region will get a SMS blast. And there are speakers installed along the coastline. They'll start blaring the alarm, which means the villages, the cities along the coastal area have to be evacuated. You have to move to higher grounds, move away from the immediate vicinity, at least 3 4 kilometers away, minimum. So, this is the sophisticated system we have put in place to manage tsunamis. We can't prevent it, we can definitely reduce the impact. Does anyone know which is the early warning institution in India? Which agency has been designated to provide alerts for tsunami? Does anyone know? IMD, no. IMD is not for everything. IMD deals with many disasters, but not everything, not tsunami. Himanshu has got the right answer. Very good. It's called INCOIS. It's headquartered in Hyderabad. INCOIS, India. All right. Indian National Center for Oceanic Information Services. It specializes in oceanic research and oceanic data gathering. So INCOIS Hyderabad is the nodal agency which has created a network of sensors across Indian Ocean, even in the Arabian Sea. Because historically, tsunamis have happened in Arabian Sea as well, which have hit the west coast of India. All right. So across Indian Ocean, these underwater sensors, buoys are deployed, which are connected with our satellite networks that provide for real-time alerts and real-time tracking. So the impact is very clear. I don't even have to explain. There will be loss of life, loss of infrastructure, degradation of your coastal environment, mangrove forests, coral reefs, coastal wetlands. They will all suffer severe damage, which can harm the biodiversity as well. So there will be big environmental impact. The coastal flooding will destroy the fishing villages. They will bear the biggest impact. The boats of fishermen will be completely destroyed. Tourism will take a long term hit. The coastal flooding will cause severe pollution. Water sources will get polluted. Water will not be fit for drinking because saline water will mix with all the water bodies. Then, agriculture, fishing ponds, they will all get contaminated with saline water. So, there will be a very big economic loss along with severe damage to infrastructure. Roads, power cables, railway lines, power plants, your airports and seaports, your city infrastructure, everything could take a hit. Is that clear? So, this is the impact of a tsunami. Now, look at the vulnerability of India, Andaman Nicobar, and the whole east coast from West Bengal till Kerala, and even West Coast can potentially witness tsunamis. In the modern times, we haven't seen this, but historically, there are references to show that many, many decades ago and centuries ago, there have been tsunamis towards the West Coast as well. Got it? So please note down the name of INCOIS. INCOIS Hyderabad. It acts as the Indian Tsunami Early Warning System, established in 2007, and it provides this service to 28 Indian Ocean rim countries. As we are a regional leader, right? Not every country can invest in this technology, right? Bangladesh, Sri Lanka, Myanmar, they can't have this wide network of tsunami early warning systems. So we work with Japan, US, Australia, and Indonesia, and we provide alerts for all the countries across Indian Ocean. India is the lead country as part of the Intergovernmental Oceanographic Commission of UNESCO. Our INCOIS has been designated as the Indian Ocean Tsunami Early Warning Center. For whole Indian Ocean, INCOIS Hyderabad is the warning agency, not just for India. Right? We can't keep this information only with us. We have to share it with all the 28 Indian Ocean rim countries. So there is a communication system for this where the alert goes out in real time. We coordinate with Indonesia and Australia, even US and Japan have the technology. So we work together to provide these real time alerts. This is how we are assisting other countries as well in disaster management. Now, one way to contain the impact is by protecting your natural buffers. Mangroves, wetlands, and the tree cover can play a critical role in arresting the floods, also in cutting the impact of the wave. They will absorb the bigger impact. These are natural defenses. So this is a valuable lesson we learned in 2004. That's why in the last 20 years, governments have protected and enhanced the mangrove cover of India. Next, of course, it's exactly same as cyclones. Every other measure is the same as cyclones, nothing different. Building shelters, cyclone tsunami shelters are the same. Land use planning, that is your coastal regulation zone rules to regulate human activity and construction. Creating structural measures like embankments, barriers to divert the floodwaters, right? Providing insurance, all these basic measures which we have already covered under cyclones. The same will apply here as well. Understood? Now, before I move on to the next topic, I would like to give you one more example as a case study. In the year 2011, there was one very unfortunate event in Japan. I'm sure you would have heard about the Fukushima nuclear disaster. It was a nuclear disaster that happened, but it occurred because of a cascading effect. All right, let me tell you what happened. In the Pacific, that's in the Pacific Ring of Fire, there was a major underwater earthquake that occurred. This underwater earthquake triggered a massive tsunami, and this tsunami wave crashed into coastal Japan. Fukushima is a coastal city. There is a nuclear power plant located on the coastline, and the tsunami wave flooded the Fukushima power plant as well. The flooded waters, they started rising in the power plant. According to International Atomic Energy Agency, IAEA is the nuclear regulatory authority. It lays down safety standards, security standards for nuclear plants around the world. Even India follows the same standards. According to IAEA, the moment there is an earthquake, there should be an automated system which detects the earthquake and shuts down the reactor to ensure the safety of the reactor. To prevent a bigger nuclear accident or a disaster, IAEA has mandated that every nuclear plant in the world should have an automated system. The moment they pick up earthquakes, the tremors, automatically the reactor has to go into shutdown mode. All right? The same thing happened in Fukushima. The moment the earthquake happened, it was detected and the reactor started shutting down. But the problem was when the reactor goes into shutdown mode, regular power supply is cut off. Regular power supply is cut off and it switches to a backup power system. Since the plant is shutting down, the reactor is being shut, regular power is cut off and there will be a backup power system which takes over. Now, power supply is critical even after the nuclear reactor is shut because the coolant has to be constantly pumped to keep the reactor cool, because the temperatures will be very, very high, thousands of degrees Celsius. Even if you shut down the reactor, the temperature will remain high for many, many hours or days. So coolant solutions are important. The coolant system will keep functioning. So for this, there will be backup power supplies created. But unfortunately, at Fukushima, there was a design flaw. The flooded water destroyed the backup power supply. The sea water which flooded because of the tsunami, it took off the backup power systems, thereby shutting down the coolant supply as well. Ideally, Japan should have created even more backups. You should have complete redundancy built into such a system. Redundant systems are critical in these important projects. Redundancy means for a backup, there should be another backup. For that, there should be another backup. There should be 3, 4 fail-safe systems. That is how such projects are handled. You take space missions, for example. You can't afford even a single mistake. If one system fails, there will be multiple backups. For backup, there will be another backup. That is how it works. That's called multiple redundancy. In this case, Japan had failed. It had made a mistake, a horrible mistake. There was only one backup power system which was taken offline because of the flooding. And since cooling got shut down, right, the pumps which were pumping the coolant, they were completely shut down, causing the meltdown of the reactor. The high temperatures persisted even though reactor had been shut. The reactor melted and radiation leaked into the atmosphere. The soil, the water, the atmosphere got polluted with nuclear radiation, and it persists even today. Recently, it's been in news. The whole site was isolated and quarantined. Now, Japan has collected all the wastewater which is contaminated. It's apparently treating that water to remove the radioactive contaminant, and it's releasing the water back into the sea. So, that has triggered a separate controversy itself. But please understand that disasters can have this cascading effect. Earthquake triggered a tsunami, caused a coastal flood, which led to a CBRN hazard, right? A nuclear incident is a CBRN hazard. So that is why I gave this example. All right. So now nuclear reactors are much safer. Many countries have taken a lesson from Fukushima. They've all created multiple redundancies to ensure at any cost a nuclear plant should not fail. Understood? That is called nuclear resiliency, right? This can be applied for any project. Disaster resiliency can be built in any project, be it a dam, be it an airport or a seaport or your house or a government complex. Any structure, any infrastructure can be made resilient to disasters. That's why India has a global initiative. Now, take this as an exercise, take this as homework. India has a global initiative. We have launched it. It was an initiative of Prime Minister Modi to bring resiliency in disaster management, to promote disaster resiliency. So, read about this and we'll discuss that in the next class. Next Saturday, when we meet, we will discuss this initiative of India. So, please take that as homework. So, this completes my discussion of geophysical hazards. So, now let's take up one more topic for the day. We still have 45 minutes to go. We can easily finish one more topic and we'll be left with very few topics for the last class. Let's discuss a biohazard. Let's talk about epidemics and pandemics. Now, given that we have recently come out of a pandemic, all of us have experienced the devastating impact of a pandemic. I'm sure this topic will be more interesting and easier to understand. I'm sure all of you are very well aware of all the dynamics of a pandemic. I just have to summarize, give it a structure, and discuss the basic concepts. So, what causes an epidemic or a pandemic? Obviously, it's pathogens, microorganisms. They may not be visible to our eye, but they can wreak havoc on humanity. They can disrupt the whole world, and they literally shut down the whole world. Right? That's what we saw in 2020 when COVID-19 broke out and became a global pandemic. So, any such rapid spread of infectious, contagious disease, right, is seen or it's called as an epidemic or a pandemic. It's designated as an epidemic if it is affecting one particular region, if it's affecting maybe few countries, if it's affecting maybe few countries or one given region, then it's called an epidemic. Let's say only 2-3 countries are affected, or maybe 3-4 countries in a particular region are affected. Maybe that's where the disease is spreading rapidly. There should be a rapid spread. There should be an exponential rise in cases. It becomes a pandemic if it goes global, meaning multiple nations will report the infections. They will all witness exponential surge in cases, causing uncontrollable spread in the community. That's when it becomes a pandemic. So your epidemic turns into a pandemic if not controlled. All right, and there are other factors as well which could turn an epidemic into a pandemic. So epidemic and pandemic are exactly the same. Only difference is in the spread. Both are contagious infectious diseases which affects human health, causes death, causes severe economic and social damage. All right? Epidemic is restricted to some countries or one particular region, whereas a pandemic is global. Multiple countries will be affected where community spread is happening, millions are getting infected. All right? Any idea who declares an epidemic or a pandemic? Any idea who has the powers to identify an outbreak as an epidemic or a pandemic? Very good. It's the WHO. WHO is the nodal agency, the World Health Organization. Now, can you give me any examples of epidemic? Two, three examples. Two, three examples of any epidemic. Ebola. Very good. Jayant has said Ebola. Ebola affected few African countries, particularly in West Africa. Nipah wouldn't exactly qualify as an epidemic. Nipah is an infectious outbreak, but Nipah is not an epidemic. Why? Nipah does not spread exponentially. Please understand. Understand the epidemiology of how a disease spreads. Nipah, it has been seen in Malaysia, in Singapore, in Bangladesh, and India, especially in Kerala and West Bengal. In Kerala, we have seen multiple outbreaks, including the latest one which happened just few weeks ago. Doesn't mean it will become an epidemic. Please understand, there should be exponential curves where the cases are rising rapidly. That never happens with Nipah. Nipah spreads very slowly because the transmission is little difficult. It doesn't transmit so easily from humans to humans. All right. Now take the latest outbreak in Kerala. Few people were affected, few people died, but it didn't turn into a mass outbreak. Epidemic or a pandemic is where exponential rise in cases are happening. Every day, thousands, lakhs are getting infected. Thousands are coming to hospitals. Hospitals will run out and people will start dying in large numbers on a daily basis. That is an epidemic. All right. So Nipah is not an epidemic. Have you heard of Zika virus, which mainly affected Brazil? There was an outbreak in India as well. Zika can become an epidemic, right? Of course, there are others. Plague, you have polio, TB, all of them. They have epidemic potential. Now, any of these diseases can turn into a global pandemic. See, with regard to coronaviruses, the coronavirus family, we have seen previous epidemics like SARS and MERS. Coronavirus family is well known to us. We know it's highly contagious. We have seen previous outbreaks like SARS and MERS. But there are certain deadly pathogens which mutate in such a way. And when they make this zoonotic jump, that is when they jump from animals to humans, that's a zoonotic jump, right? These pathogens could be novel pathogens, meaning it's new. It's not known to humanity, or humans have not been infected before. And we don't know about it. We are not aware of it. When such a new pathogen comes up, the pathogen could be anything. It could be a virus. Don't assume epidemics, pandemics happen only because of virus. It's a wrong assumption. Even a bacteria can trigger a epidemic or a pandemic. Even a fungus and algae can trigger such outbreaks. There are many possibilities. There are many microorganisms which we don't even know about. There could be ancient microorganisms dating to billions, millions of years, which are locked away in permafrost, in the Arctic, in the Antarctic, in the Siberia region, where things are frozen from millions of years. There could be these ancient pathogens which we don't even know about, and they could get unlocked. We call them zombie viruses or zombie pathogens. They're all coming back because of global warming. There is this fear, there is a theory that global warming, which is driving the melting of ice caps, glaciers, and polar ice caps, can reintroduce these zombie viruses which are frozen, which are in permanent thaw. So when they start, entering back, if they make a zoonotic jump, if they enter human beings through some mutations, then it could be a novel pathogen that could have deadly impact. Right? You might witness many more pandemics in the future. So these outbreaks that happen on a global scale, like COVID-19, that is a pandemic. Is that clear? The plague went on from being an epidemic to a pandemic many, many centuries ago. The plague devastated populations around the world. Civilizations were brought down, right? That is the potential. Civilizations have been ended because these biohazards are apocalyptic. They have apocalyptic potential. Just like a mega volcano, mega meteor strike, they can wipe out life on Earth, at least most of it, right? So I'm not exaggerating here. This is a possibility, a very, very real possibility. So we are fortunate that we haven't dealt with such mega epidemics or pandemics, but the potential is always there. So COVID-19, the plagues, then the Spanish flu, right? All these were major pandemics. HIV AIDS at one point, then H1N1, which is a type of influenza. All these have turned out to be pandemics. But in the last century, we haven't experienced anything like COVID-19. The last major pandemic was the Spanish flu, right? Right after the First World War in 1920s, that is when this mega pandemic was seen, 1919, 1920. Almost a century later, we saw COVID-19. The scale, the spread of COVID-19 was something else. The other pandemics we have seen in last 30, 40 years, they've died out very quickly. But COVID-19 was something else. So this disease that can spread in a population in a very short span of time, where you see these exponential growth in cases, this can have a huge impact because they can overwhelm your health infrastructure. So many cases can occur that your hospitals will get over flooded. They'll be overwhelmed. You'll run out of hospital beds. You'll run out of medical facilities and systems and doctors to even handle the patients who are coming in. So that is the true scale and impact of a global pandemic. Now, there are many factors that play a role in determining the risk associated with epidemics and pandemics. For example, immunity. What immunity do humans have against a particular pathogen? There are certain pathogens which we have been exposed to, right? So naturally, immunity would have been built up. But novel pathogens which are entirely new to humans, like COVID-19, that's why it's called the novel coronavirus or novel SARS coronavirus 2, right? COVID-19 was novel to us. It was new. We had never experienced it before. Even though coronavirus family and the SARS family was known to us, this particular variant was completely new to human beings. We still don't know the source. Many studies have been conducted, many investigations have happened. All theories have been explored, from wild animals to even possible bio attacks, right? All the theories have been explored. But most evidence is indicating towards a natural source. Most of the available evidence points towards a natural source. Of course, there are a lot of theories and even conspiracy theories that it leaked out from the Wuhan Institute of Virology in China. It was a man-made, lab-made virus. But by and large, these theories have been put to rest. Even the CIA of the United States, most intelligence agencies, and most of the healthcare researchers, they've all pointed towards a natural source. That is what the evidence is pointing towards. Maybe we'll never find out the true source, but large evidence is showing us that it was of a natural origin. So don't fall into conspiracy theories. I know many of you will ask a question that did China release this? Was it a bio attack? Right? See, no country would have deliberately done it. No one can gain from this. You can't really control how a pathogen spreads. but there might have been an accidental leakage. Might be, right? Given the proximity of Wuhan Institute of Virology to the wild markets where the meat markets where it spread, there is a possibility that it might have been a lab leak, accidental leakage. But however, it's never been proven. We haven't got enough evidence to show it's man made. And most evidence are pointing towards a natural source. Maybe some animal, some vector pushed it to humans who are in close contact with it. Maybe those who consume wild meat, bush meat, those who work with some wild animals like bats or pigs, right? Civet cats. The source could be anything. So most evidence points towards such a natural source where it made a zoonotic jump to humans. The moment the outbreak occurred in Wuhan, China failed to act on it. This is where China made a big mistake. Even though signs were there as early as October, November 2019, China was very slow to act. Even though doctors were reporting very abnormal cases, right? There was a very slow and disappointing response from China. It kept the world completely dark about these initial cases. China said that initial cases started in December 2019. And this is a lie. It's been proven as a lie. Evidence has shown that initial cases began maybe somewhere around October to November or even maybe in September. So, good 3 to 4 months, or at least 2 to 3 months, were lost because of China's lack of transparency. As an authoritarian country, it tried to contain the crisis to not inform the rest of the public and the rest of the world. It kept even WHO under dark. It didn't inform the countries on time, and by that time, it was already too late. By the time it announced, right, it was only in January 2020 that the world got a fair idea of what was happening. By then, it had already spread to multiple countries. Multiple outbreaks were being seen by Feb 2020, and it had already become a pandemic by then. Massive outbreaks came up in Italy, in Iran, in Japan, in South Korea, and very quickly it devastated Europe, US, and rest of the world. Correct? India was a little fortunate initially, right? Until Feb, we were spared of the major cases. It was only from March onwards we started seeing the initial cases. But by then, the WHO had slowly woken up to the threat. This is where WHO is also criticized for its mismanagement. See, China kept everyone in the dark. For that, you can't blame WHO entirely, because WHO has no powers to force countries to share information. That way, it's a very ineffective organization, right? There is an organizational problem. So it has no enforcement powers or penal powers. It can't punish any country as such. So China conveniently kept everyone in the dark, didn't even inform the WHO. And by the time it informed, it was already too late. It had already leaked out. It had spread to many countries by then. So WHO took even more time. Ideally, by Feb, it should have declared a pandemic. It delayed the decision making. This is where it faces a lot of criticism. It was only on 11th March that a pandemic was declared. Right? So, following this, most countries went into strict lockdowns because there was no other option left. Otherwise, your healthcare systems would be overwhelmed. We saw what happened in Wuhan. We saw what happened in Italy, in Iran, in South Korea. Right? People were struggling to get hospitals. They were dying without oxygen, dying without medical treatment. Especially those with comorbid conditions, old age people, compromised immunity. They were at greater risk. So, to give time for the healthcare system to prepare, for the government to prepare, most countries went for a lockdown, including India. So, immunity and these epidemiological factors, they play a critical role in determining the spread and the impact. The virulence factor, how virulent is the disease? That is, how easily does it spread? What is the route of transmission? The most contagious diseases are the ones which spread through the aerial route, where air transmission is possible through respiratory route. This is the easiest to spread because they will spread with touch, with contact, and even with the droplets. See, that is why other diseases like Nipah and HIV/AIDS, they don't spread so quickly. Why do you think HIV/AIDS doesn't spread? Because there is a certain transmission route. Only through certain routes it transmits to others. Human to human transmission happens only under certain limited circumstances, like unsafe sexual intercourse or drug usage, right? Or getting in touch with contaminated fluids, contaminated blood. So there are very specific routes through which HIV/AIDS spreads, right? Like Nipah as well. Nipah has a very limited transmission. But when it comes to respiratory diseases like SARS coronavirus 2, that's COVID-19, MERS, they spread through the aerial route. So every time you talk, you sneeze, right? And every time you touch your let's say your nose, your mouth, your eyes, right? Your hands will be contaminated. And any surface you touch or wherever your droplets fall, right? Your saliva, nasal droplets, wherever they fall, everything becomes a contaminated zone. So whoever comes in contact with these surfaces, like tables or door handles, taps, etc., or even in close ranges where aerial transmission is happening, right? That is where the disease spreads very quickly. That's where you see the exponential growth happening. All right. So this is determined by R naught. R naught is the reproductive rate, the reproduction number, the rate at which it is spreading. R naught tells you how many people are getting affected by one infected person. If R naught is less than 1, it means one infected person is infecting less than one person. So you will not witness an exponential growth. It means the spread is contained. If R naught is equal to 1, it means every person is spreading it to one more person on an average. So you might see a decent spread. But the moment it crosses 1, it touches 1.5, 2, 2.5, it means that you are going to see an exponential curve. This is where the exponential rise in cases happen. Meaning every person is infecting more than one person, maybe 2 or 3 people or more than that. So R naught plays a critical role. The rate at which it's spreading, the virulence, it depends on the mutation of the virus, how it's latching on to our body, how it is infecting, what is the incubation period, because these pathogens will not immediately affect. They'll take some time to incubate, right? And what is the route of transmission? All these factors play a role. Next, of course, the vectors and the host, the reservoir host, like bats, pigs. There are some animals, birds, which are reservoirs of many dangerous pathogens. Bats especially are very dangerous in that regard, fruit bats. There are many vectors which carry them. They themselves don't get affected, but they act as a carrier. They give it to others, right? Like mosquitoes or other animals in between, maybe cats, dogs, pigs, right? Birds, etc. They could all be carriers. They could all act as vectors. So whoever work in close contact with these animals, right? Consumption of wild meat and bush meat. This is where climate change, environment destruction plays a role in epidemics and pandemics. I've seen that many students get surprised when I say that global warming and environment destruction contributes to epidemics and pandemics. Because see, please understand the link. If we are deforesting more areas, if we are killing more wild animals and consuming them, right? This is dangerous because there could be reservoir hosts or vectors of dangerous pathogens which we have never encountered in human history, which means we have zero immunity against them, right? So when you're destroying the environment, you're releasing more pathogens. Like global warming is melting the permafrost and ice caps, releasing ancient pathogens, right? Some of them might be very dangerous and it might make a zoonotic jump. If you're consuming wild meat and bush meat, right? There are many tribal cultures in India, in Africa, in Asia, where bush meat, wild meat is consumed. It's part of their culture, right? But there is a risk. The risk is that some of the wild animals could carry these dangerous pathogens, and in today's globalized world, it will spread very, very quickly because of air travel, because of easy connectivity. It's going to break out everywhere, right? So, environmental degradation, deforestation, climate change, they do play a direct role in the release of more deadly pathogens. That's why many epidemiologists who specialize in the dynamics of an epidemic, they're all worried. They are sounding the alarm from many years that as the global temperatures increase, as we continue to pollute and destroy our environment, we might see many more dangerous pathogens causing epidemics and pandemics. COVID 19 is not the last. It will happen, right? It's only a matter of time. So, experts are worried we might see even more dangerous variants where the mortality rate is deadly along with high exponential growth. Till now, we have been fortunate that diseases like Nipah has a mortality rate of 70%. 70% of infected people will die. Fortunately, COVID 19 had low mortality rates, even though it was spreading quickly, right? Nipah doesn't spread quickly. That's where we got lucky. COVID 19 had a slightly lower mortality rate. That's where we got lucky. Ebola has a very dangerous mortality rate. Almost 90% will die, right? But fortunately, it's not spreading quickly because of the difficulty in transmission. If tomorrow there is a pathogen which can not only spread quickly and easily, but kill more people with high mortality rate, right? That is a extinction level event, right? So that is why pathogens have apocalyptic potential. Many epidemiologists have kept warning governments and WHO about this to plan, to prepare, to share data, to share information, because it is possible to contain the spread. We have enough advances in medical sciences today. There are better standards, protocols available today through which you can contain and limit the spread. But it requires a global collaborative effort, and that is what is missing. And unfortunately, we haven't learned the lessons even after COVID 19. If you saw during COVID 19, countries were blaming each other, fighting against each other. No one really collaborated. There was no real global collaboration, right? UN was ineffective, WHO was ineffective. Only few countries collaborated bilaterally, right? India gave some assistance. We worked with other countries. But apart from that, there was no structured global response. So the mobility plays a key role, the speed and volume at which it is spreading. Social, cultural factors, the amount of touch that happens in a social, cultural setup plays a big role. Because, see, in many cultures, handshake is common, hugs are common, kissing is common, right? You greet others with a peck on their cheek. For example, in West Asia, giving a handshake is very common in Western culture, right? Hugging is very common, right? So, this depends on your cultural, social practices as well, which means there is more contact, and as a result, the spread will be higher. Religious events are a major hub. Religious events, religious gatherings, right? Or public rallies, political rallies. Depending on the society and culture, these could become factors in driving the spread of a disease. That's why COVID 19 witnessed these clusters wherever religious processions and gatherings were happening. Is that clear? So, social cultural practices play a role along with drug resistance, because we have abused certain critical drugs like antibiotics, right? There are many vital drugs which are the basic line of defense we have, but we have abused and overconsumed them. We have self medicated ourselves, leading to drug resistance getting built up in our body and as well as in the pathogens. The pathogens have mutated to build resistance against the drugs. Our immunity has been compromised due to drug abuse. Drug resistance has come up. So these factors, they could play a role in determining the lethality of an infectious disease. All right. Now, if there are outbreaks, what do you do? I think you guys can give me the answers very easily, right? At least with regard to the measures, the disaster management measures, I'm sure all of you are aware because of COVID 19, right? So the measures are very simple. Have a effective early warning system, which means governments have to share information transparently. They should not hide. The reason why governments hide is that there is a stigma associated with it. Countries get blamed for it, right? This is human nature again. Even within our own country, when initial cases came up, those whole families were stigmatized, right? People wouldn't talk to them. They would look down upon them as if they have done some great blunder, right? This is natural. Nothing can be done unless you're showing irresponsible behavior where you're not following the protocols. Until then, you can't be blamed. No one can be blamed for this. No country or no government, nor no person can be blamed for it, right? Unless there are deliberate mistakes done. So China's mistake was it failed to share data and information. It kept us in the dark. That is where it made a big mistake. That's where it deserves criticism. Not because conspiracy theories tell that China released this pathogen. It was a lab-made pathogen. Those are all conspiracy theories. So sharing information is crucial along with disease surveillance. There should be a well-established surveillance network to look out for these emergent diseases. Across the country, across the world, constant watch has to be maintained. Hospitals, doctors, testing labs, diagnostic facilities, they should all know that if they find something abnormal, they have to report it. India has a disease surveillance network in place, right? We have made it a real time database where different outbreaks are logged. All the test results are logged in a common database. If something abnormal comes up, the government gets to know, the Ministry of Health and Family Welfare will get to know that some abnormal disease is spreading. So this gives you the early warning. You can immediately contain the spread through better sanitation hygiene, right? Washing hands, wearing PPE kits and gloves, using sanitizers, strengthening public infrastructure, preparing your hospitals, quarantining, quarantining the patients and even the suspects, right? Whoever has come in contact with the infected person, they have to be quarantined. Furthering your research and development to develop better drugs, to develop a possible vaccine, right? Your biotech industry, your pharma industry, the medical science industry will play a critical role in designing new protocols, new medicines, new lines of treatment, and if possible, developing a quick vaccine. Until then, you have to rely on your social vaccines, like maintaining social distancing, wearing masks, maintaining sanitation and hygiene, washing your hands, sanitizing surfaces, right? All these are basic social measures through which you can limit the spread of the disease, right? These are some responsible measures and basic measures expected out of everyone when epidemics and pandemics are spreading. In a worst case scenario, lockdowns come into picture where you shut down your economy. You ask people to stay at home and allow only the primary responders to work. The first responders, that is obviously hospitals, doctors, and nurses, police and security forces, right, and other critical government services. Only they will be allowed to function because they have to prepare for what is going to happen next. In case of such a widespread breakout, you get to a point where it can't be contained anymore. Community transmission becomes a reality. So at such points, lockdowns become critical. It's a strategic tool where you can avert or at least minimize the impact, right? You can't contain a pandemic with lockdown. Many people had a wrong assumption, Indians especially, who are completely unaware of epidemics and pandemics. They believed that the first lockdown is going to erase COVID 19, right? That's not the case. Lockdown is just a tool to delay the eventuality. Lockdown is useful to prepare for what is going to happen next. Once you lift the lockdown, the disease will spread. You will allow the disease to spread, right? But by that time, your government, your hospitals can prepare. your medical system. They can prepare, create more beds, procure more drugs, medicines, oxygens, create more ICU facilities, ventilator facilities, right? So lockdown gives the time for the first responders to prepare for what will happen next. That is why the moment you lift a lockdown, there will be a spread. All right, it will not eliminate the disease, it will spread again. You will see an exponential rise, and then you hit a plateau, you hit a flattening where you bring down the curve. So, all along, if people are responsible, if they cooperate with the government and the healthcare industry, we can manage to contain the overall impact. Many people will die, especially those with comorbid conditions, right? Those who are at higher risk, right? They will lose their lives. There comes a point where millions of people will die because of pandemics. COVID 19 has already taken off millions of lives, right? It's an eventuality, you can't help it. But what you can do is at least minimize the impact, provide better care, better treatment, save as many lives as possible. So, apart from that, your long term measures like conserving the environment, promoting health insurance, providing welfare measures for especially the poor people who are going to be uprooted because of the epidemics, pandemics, and the lockdowns, right? Now, this is where India did quite well compared to even developed countries, right? Many countries were very irresponsible in the manner in which they dealt with COVID 19, but India did a much better job. Of course, there were many mistakes which happened. For example, the way in which lockdown was imposed without notice and the two in a blanket manner did have a huge economic and social impact. It affected the migrant workers, it affected the poor population, right? And later stages, when the Delta variant broke out, when there was a rapid spread with high death count, there was complete mismanagement. But of course, those mistakes will happen in such disasters. But compared to other countries, India still did much better. And the quick development of vaccines around the world is what really saved it for the world, or things would have gotten even worse. Vaccine provides you that layer of immunity, and if you quickly disperse and spread it out, you'll achieve community level immunity. See, this can be done naturally as well by allowing the disease to spread. But if you do that, you'll pay a big price. The cost is very high. Many people will perish if you allow the disease to spread naturally. Technically, it will help in building community level immunity. Natural immunity will build in, and at one point, the virus or the pathogen will not have enough people to infect. All right. But if you do that, if you try to achieve community immunity through natural spread, many people will perish. Your hospitals will be overwhelmed. It will be a human tragedy. So, to prevent that, lockdowns become a strategic tool. These basic protocols, containment measures become a basic tool. It will buy us time to develop a vaccine. And once the vaccines are spread out quickly and administered, it will give us vaccine induced immunity that could truly help in curbing the spread of the disease. Right? So, today we have managed to tackle COVID 19. It's been well under control for more than 1 year, but there is no guarantee it will not come back because these pathogens they keep mutating. They are super smart. This is nature, the beauty of nature as well, the raw beauty of nature. Any challenge thrown at any living organism, you will find adaptation, right? Living organisms, they keep adapting. This is a way of life. All right. Even non living objects have shown adaptation. That's the very nature of our universe, right? So, pathogens, though microscopic, though invisible, they can mutate, they can adapt, and you can see different variants that could cause further outbreaks. So, that is why constant surveillance is important. Constant surveillance, along with your healthcare machinery being prepared, implementation of basic protocols like constant testing. You have to scale up testing, improve contact tracing, identify the contacts of the initial infected patients so you can try to contain it as much as possible. Isolate those contacts and the infected patients and put them under quarantine so you can further limit the spread. Communicate the risk very clearly. The government should be at the forefront, clearly telling the people what is the risk, even if it is very bad news. Some countries did a good job of communicating, like India. The Prime Minister himself came out and clearly told what is the risk. UK did a good job actually. At least the risk was communicated. The then UK Prime Minister clearly said, we are going to lose people. Things are going to get very bad. That response is very, very important. Or else people will never wake up to the threat. People are complacent. We humans are generally complacent. But US and Brazil were disastrous. Thanks to their leaders, Donald Trump and Jair Bolsonaro, these right wing leaders who don't believe in science, they made a big, big blunder by undermining the threat. They simply blamed China and without proper evidence. They largely undermined the risk factor. They refused to impose lockdowns even when hospitals were overburdened and they were running out of beds. People were literally dying on the streets in their homes, but still US and Brazil delayed lockdowns. This was an unscientific approach, very poor risk communication. So people, many of them in the US, even now believe that COVID 19 was a conspiracy. They believe that vaccines are dangerous. They believe that COVID 19 is no threat. They believe it's a imaginary fictional story which has been created. I'm not even kidding. There are Americans who still believe that. Most of them are followers of Trump. The leadership, the government, how they communicate the risk is critical in such cases. Right? India fared better. There were other countries as well which did well, like Vietnam, for example, Japan. They all did much, much better because the risk communication was clear from the government. Based on that, appropriate measures were taken. Scaled up testing, right? Contact tracing, isolation, then implementing the social measures, social distancing, hygiene and sanitation, wearing of masks, using lockdown as a strategic tool only when needed to break the wave, to break the exponential curve, or give some time to prepare for the hospitals. Lockdown has to be strategic because otherwise, if you don't plan it well, lockdowns can have a devastating economic and social impact. You need to strike that balance. This is where India faced criticism. The first lockdown, especially, right? There is a very strong criticism that the way in which it was imposed, blanket lockdown without proper basis, without proper notice, this had a devastating economic and social impact. So, better planning could have been done. These are strategic tools which should be implemented very, very carefully for certain periods of time. That gives us time to prepare and gives you the opportunity to break an exponential curve. In the second, third phases, India did very well with the lockdowns. But the first lockdown has always been criticized for its long lasting economic and social impact. So these disasters are honestly very challenging to deal with, especially biohazards, right? Be it a pest infestation, insect infestation, or other pathogens, like I told you, right? If people are not aware, right, and since it involves a bit of science, people may not understand the risk, they may not understand everything. A lot of people will turn to superstition, pseudo medicines, and that is a bigger risk, right? We saw this happening during COVID 19. That's why it's important to engage the community. Many people believed in superstition, alternate medicines which don't work, right? And they contribute to the spread. They are irresponsible in that regard. So, this is where you need more scientific awareness. The communities have to be engaged, leaders have to be engaged to spread the message. And more importantly, you have to strengthen your healthcare sector. There's no other option, right? More investments in public healthcare. Government hospitals have to be strong, not private hospitals. In India, this is major problem, right? The government investments in public healthcare is very less compared to our percentage of GDP, whereas most of the healthcare is largely in the private sector. That's why our out-of-pocket health expenditure is very high. We spend a lot of money every year per person on an average, as most of our healthcare is from the private sector, right? In these cases, it's public health institutions which play a bigger role. Of course, private healthcare also backs up the government, but public healthcare institutions have to be strong. Your primary health centers, your research institutions, your testing and diagnostic facilities, right? Your surveillance mechanism, they have to be very, very strong. So the nodal ministry for biohazard is the Ministry of Health and Family Welfare. Is that clear? So these are the various measures under disaster management. It includes health insurance, welfare schemes and programs for the poor people. Like India launched many welfare schemes when the lockdown was brought in. Since migrant workers and poor people would be affected, a lot of schemes were brought in to help street vendors, right? Then the Antyodaya Anna Yojana to provide food security, where free food grains were distributed. So many such welfare schemes were implemented by India. So that is needed to take care of the socio-economic consequences. Along with that, you need to fast track research to understand the disease better, to bring out the genome sequence, to track the mutations which are happening constantly, and develop vaccines, medicines, and line of treatment. Right? So these are the efforts needed, but India did very, very well compared to many other countries. Despite some mistakes, India did quite well. The vaccines that we produced, mass produced, Covishield and also the indigenous vaccine, Covaxin, right? They played a big role in shielding our population, in arresting the spread, and we helped others as well, right? We provided vaccines to other countries through our Vaccine Maitri initiative, the vaccine diplomacy initiative of India. This is a classic example of how India promotes disaster management assistance, that is HADR assistance, humanitarian assistance and disaster relief, through our foreign policy. We provided free vaccines to many countries, from Nepal to Maldives, Bhutan to Seychelles. Many, many countries received free vaccines from India under the Vaccine Maitri initiative. This is one example of India helping other countries in disaster management, right? We provide HADR assistance. At the start of the pandemic, we carried out Mission Sagar. Indian Navy carried out Mission Sagar, where essential medicines and supplies were given free of cost to many friendly nations. Sanitizers, oxygen, then sanitizers, PPE kits, right? Basic drugs. Everything was supplied by the Navy to many countries in the Indian Ocean, from Sri Lanka to Maldives, then even Nepal, Bhutan, right? Many East African countries like Mozambique, Kenya, and others, and Mauritius and Seychelles, and few others. They were all helped out by India through Mission Sagar, where we directly stepped up and gave assistance to these countries to overcome the disaster. All right. So we see this role of India in many other disasters. I pointed out how we provide tsunami alerts, cyclone alerts to other countries. If others are affected, right, we give them direct assistance. Like when the Turkey earthquake happened, when Turkey and Syria were hit, even though Turkey has been hostile to India, even though it has acted against Indian interests by supporting Pakistan over Kashmir issue, India kept the differences aside, and on humanitarian grounds, we carried out Operation Dost to help Turkey and Syria. We deployed the NDRF. We sent essential supplies. We deployed medical units from Indian Army to provide for search and rescue and medical aid in Turkey and Syria. That is just one more example of how India provides humanitarian assistance and disaster relief. Is that clear? So we saw this in action during the COVID-19 pandemic as well. That's the point I wanted to make. So this brings today's discussion to an end. We have covered many, many important topics, and we are just left with the last part of the syllabus. So next Saturday, of course, we have the classes which will continue. You will be informed about the timings. We'll cover forest fires and man-made disasters. That will complete all the different types of disasters. And then we'll discuss the global framework and India's disaster management architecture. These are the only four topics we are left with. And once we complete the syllabus, we'll discuss previous questions as well. Got it? So I hope it was a good, fruitful session today. I hope you guys have learned all the key concepts. Do let me know how the session went. I'll just take a look if there are questions pending. Chituri is asking, please repeat the homework. I gave you a small assignment that India has launched an initiative, a global initiative to promote disaster resilience. All right, especially in infrastructure, to promote disaster resilience, a global initiative has been launched by India. So please find out which initiative it is. I'll discuss this in the last class. A student is asking why there is no zone 1 in earthquake zoning. That's because zone 1 places are safe. They don't witness earthquakes or they're not affected by earthquakes. So there's no point in representing zone 1. Vivek is asking consequences of 5 or 6 magnitude earthquake. 5 or 6 magnitude earthquake can cause very severe trembling. It can lead to cracks in buildings. Like I said, old, unstable buildings can collapse as well. But the damage is slightly minimal. All right. Compared to 8 or 9 magnitude, it's slightly minimal, but still, it can cause significant damage. There could be loss of lives. How many earthquakes happen in a year? How can you say that? It can be zero, it can be any number, right? It's unpredictable. You can't really put a number on how many earthquakes happen in a year. 2004 tsunami name. There was no name given to tsunamis. Tsunamis are not named. There's no naming system for tsunamis. Please repeat R naught. R naught is the reproductive rate, the rate at which the virus or the pathogen is infecting and spreading to other humans. It tells you how many people one infected person is infecting in return. All right. If R naught is less than 1, it means one infected person is spreading the disease to less than one person on an average. If R naught is equal to 1, it means that one infected person is spreading it to another person. If R naught is above 1, if it is 1.5, 2, 2.53, it means that each infected person is spreading it to more than one person, meaning 2, 3 people are getting infected. So that is where you see an exponential rise in cases. If R naught is above 1, that is where you see the exponential growth in the curve. Deepesh is asking, are vectors and reservoir hosts the same? No, they are not. Reservoir hosts like bats and pigs, they are the reservoirs of many, many pathogens. They are the primary source, right? They are the host animals. Vectors are the ones carrying it, like mosquitoes, dogs, cats, even pigs and birds. They are the vectors which carry it from one source and infect humans. All right. So reservoir, host, and vectors are different. All right. So, guys, these were the questions. So let's end the session for today. I'll see you next week, next Saturday. We'll wrap up the few remaining topics and complete the syllabus on next Saturday. So that is it from my side. Thanks for watching. Do let me know how it was. I'll look at the comments later and take care. I'll see you next weekend.